Whatever this numerator is going to cancel out because it's one of that over one of that.
No, I mean like,
It's 1 over seconds. Sometimes, depending on the order though, if it's like second or it's 1 over molarity seconds.
What's it's not always.
No, don't worry about the order in these problems.
Oh wait, I didn't solve it.
Hold on. Does it seem like it should be wrong? Work with me, Nick. Reason should tell you, no, that doesn't seem right.
That does not.
2,400 years to that.
It's a lot smaller than 2,400, guys.
I want to give everybody a chance to go ahead and calculate. I want to make sure you can do that algebra.
Yeah, it's so weird.
Do the problem.
I did.
I don't know. That's what somebody was saying last hour. Ah, this is just a zoomed out made up problem. Maybe it is. I don't know.
Take the emergency gas.
Probably so. Probably so. Yep.
Mr. Moore. Mr. Moore.
Yep.
But he
All right.
actually took the emergency gas shut off.
Oh, good. Good. Yeah, that'll work. Now, here's what we do. Take negative 184 minus negative 59. Just get an answer for that. It's going to be negative 100 something. Then divide it by 0.00831. Divided by 600. Then that answer raised to the power on e. That's going to give you an e to the negative 25th, if I remember right.
Times 2.
That's what I'm telling you.
3.117 times 10 to the negative. As my
No, just this side. It's e to the negative 25th. Then, what? E to the negative 36th?
Wait, no. No, just that side. But it's supposed to be. What is she saying? I just solved for us.
I don't even.
Huh? It is negative 25.
Shunak, did you get e to the negative 25th?
For that? Just for that?
Yes. Negative one, 184 minus, yes, negative 59.
So, yeah. I don't 3.8?
3.1. Yeah.
Oh no, you're not doing anything wrong. Then multiply by 2400.
Oh, wait, I did that.
Yeah, you're doing fine. All right, Chanel, did you look at that and say that was not, it couldn't be right?
Oh, yeah.
That's what I told everybody. When you look at your answer, you say, no, this is wrong.
Yeah, it is.
Is this supposed to be really, really small?
You're going to get about 3.1
Yes.
times 10 to the negative 8.
Yeah. Yay!
Oh.
Get it right.
Now,
Yay! That's so. How is that?
okay, now I was just curious. Last hour I said, okay, now this is so wacky. Uncatalyzed, this reaction is going to take 2,400 years to complete. Put a catalyst in there. Now look at the activation energy. It goes down to 59. 59 still seems like a decent amount of energy, doesn't it? Yet this thing, if you change it into seconds, it takes just under 1 second.
What? Wow.
Isn't that crazy? You think, how could that be?
Is it the Kelvin? Like,
Yeah, I mean, you can take this number, multiply by 365, that's how many days are in a year, then multiply by 24, that's how many hours in a day, then multiply by 3,600, that gets you into seconds. And that is like 0.96 or something.
Where's your 9? 0.1.
Should have been 0.9 though. But anyway, it's less than a second.
Dang.
Now, let me give you another visual to give you an idea of what just happened. You're a trusting man, Nick.
Oh, you're gonna blow up our mind.
No, I know this is not a mind, but this is going to help to conceptualize it. It had to be a spontaneous reaction to occur, even if it took a long time. This is a high activation energy. It's what a high activation energy means. Here's the reactants. The reactants are at a certain temperature. They're moving around. Only the reactants that run into each other with that much energy are going to make products. How likely is it that the reactants that have that much energy are going to run into each other? Not likely. So it takes so long because it's only a very rare occurrence that the reactants are going to hit each other with 184 kilojoules of energy. What's easier for the reaction to occur is if a catalyst is added. Now remember, a catalyst normally will disrupt the pathway and have the reaction go through a different mechanism. I'm just going to keep it at one step. That's what the catalyst does. This 59 is about a third of 184. So I made a hill that's about 1/3 the height of the original hill. Now, the reactants that have that much energy in their collision are going to rearrange. It's just about every collision is going to cause a reaction when the activation energy is that low. Does that make sense? Does that help you to see that? So yeah, I mean, when I look at this, I think, oh, 59 kilojoules still has a pretty high activation energy. But it's high enough now that almost every collision has a reaction that goes with it. Where in the first case, this hill, once in a great while, a collision is going to have a reaction that accompanies it.
So the red dot thingy is.
This would be catalyzed. This is before it got catalyzed. This is the uncatalyzed version.
Or is it more sweet? Or easier to understand, I guess? I don't know.
What, the red?
Yeah, like.
Remember what activation energy is. When particles collide, they need that amount of energy, called the activation energy, to break apart. If the activation energy is this tall, this is the 59, catalyzed, that means the particles need 59 kilojoules when they run into each other in order to break apart and make products. That's going to be very likely. When the reaction needs 184 kilojoules, that's not likely. So there's a very slow reaction because most of the particles run into each other, they just bounce off without reacting. Once in a great while, they'll bounce into each other and rearrange. That's what a high activation energy means. It means that that most of your collisions are not going to result in the reaction occurring. Roxy?
How long do you think it will take for a diamond to decompose?
Oh yeah, it would take
Much more than that?
yeah, more than 2,400 years, I think. Yeah, yeah,
Wow.
maybe in the millions or billions of years.
100
We
generations.
can wait that long.
Yeah, right.
So
right.
3 billion generations.
Yes.
Not too bad.
Okay, anything else here about this? Let's see, 1109. Okay, now for the next problem, we're not going to go through and do the whole thing. I just want you to set the problem up. No calculators allowed.
No.
So if you are touching your calculator, I'm going to throw something at you.
I'm gonna define
Vinny says,
you.
okay, Mister, I'm going to challenge everything. I'm
Oh no,
ready
I'm not
for
going
it.
to challenge you.
Look what I got my glassware up here.
I realized that you were a rugby player when you were in high school, I think.
You are?
Mr. Moore.
Wait, you played rugby?
All right,
Played
Doesn't
rugby?
seem like
Oh, sorry.
He seems
try
like a
this
nerdy
one.
type.
This one is similar. You're going to have to use this setup. In fact, I'll erase what I have down here.
I wasn't challenging it, I was putting it away.
I know what you're doing, Vinny.
I was pushing
I
it away.
can't do math without a calculator.
I was just pushing it like that.
Give it a little. I'm watching.
Oh.
You're doing no such thing, Len.
Ew, Celsius.
I gotta get this, I forgot. How to do this already. Hi. Wait, so we're not doing any calculation, we're just setting it up.
Stop that.
Oh. Yeah, boy, I'm intimidating.
Schnook, stop using your calculator. Wait, what? It's just on my desk.
No. You're not gonna. I just want you to set it up, and that's it.
Wait, why am I doing this in your
You were doing that anyway. My notebook?
Yeah, I've been taking notes for you.
Oh, I thought it was your
You
you should have
ungrateful
done it in
little-
yours. I would have done it anyways later.
Now, I
was
want you
going
to
to
see
leave.
this problem because I don't want you to be conditioned to think that when you do the k over k, that you always have to put something in the denominator. When do you have to put something in the denominator? When it gives you time. They're not giving you time in this case. They're saying that the catalyzed reaction takes 2,500 times, or goes 2,500 times faster than the uncatalyzed. So the ratio of the K's is a 2,500 to 1, or a 1 to 2,500 ratio. Not 1 over 2,500 over 1 over whatever.
What? 25.
Yes.
So you're not putting the 2,500 in the denominator of one of them.
Denominator.
That just,
Oh, it's just for
that
that.
just confused
one.
me.
Okay, yeah.
Wait, what?
Just do it your way.
It's like saying CMN,
I ha-
CMN,
okay.
You're so sad.
Indemnity? Yeah, that's, oh, that's 2,500. Oh, wait, no, the catalyzed, I'm stupid. No, I mean, I haven't even set it up yet, I'll check with you. Or the first one. E, negative EA. What is the EA for the second one?
There is. You're supposed to find that.
That was gonna be cool if you actually jumped.
Wait, what happened? You know what I'm doing it. What's
Oh, you're calculating it. It's more. So uncatalyzed, we're trying to find it with uncatalyzed, so
Okay,
negative
this
EA.
is
Over, so, it's given in kilojoules. What's 37 plus 273?
Who's got it set up?
Someone.
Do you?
It's 310.
I don't know.
Okay, do it on the smart board.
I'm scared now.
Do it.
No.
I will totally take one for the team.
Okay, let's check.
No. Go up there
No.
so we can critique your work.
No.
How?
So I can judge you.
Critique,
And
I
then
mean,
he can
wait,
judge you
critique,
too. For the first time ever.
And everyone wants
Go
to
ahead,
be
Brox.
surprised.
Let's see it.
I don't know if this
I trust you got it right.
Come
I
on.
honestly don't think so. I
Get
don't
your
know.
butt over there.
All right.
I just used the only that equation.
Nick, you got it on the smart board there? The smart board.
Yes.
Yeah, Nick's using a board that's probably smarter than mine. It's all about the user. Okay, come on over here with your board, Nick.
Actually, it's switched around.
I'm
the
hungry.
Oh, wait.
Are you
Yeah,
hungry?
yeah.
Let's just see what you have. Oh!
Come on.
Whoa.
I can't.
Nope.
Anybody else?
More.
Well, let's see. How much does this look like that?
Zoom in.
Now, oops. So you put K of uncatalyzed over K of catalyzed. That's a 1 to 2,500 ratio, right? Because this term is 2,500 times bigger than that term.
2,500.
Yeah?
25,000
No.
actually.
Yeah.
2,500.
Never mind, I'm sorry.
Or is it 2,500? No, it's 2,500.
I'm sorry.
Okay. Now you had started, you missed something. You canceled out your RT terms?
Yeah.
Yeah,
Are you sure you can?
Yeah, because it says constant.
yeah, I'm pretty sure.
You should have showed
I mean, I don't know what T. I feel like we can.
That's not the magic.
I don't think you can. I don't think you can cancel them out. Now, other than that, what do we see here? Yeah. Okay, here's what Nick and Muhammad did. They have K of uncatalyzed over K of catalyzed. The denominator is bigger on this side. Now, over here, we have e to the 50th power, which should be negative.
Yeah. Muhammad erased the negative when I was picking it up.
Could you like rewind
Okay,
this? We can
e
see
to the negative 50th power. All right. You guys are fired.
They were never hired anyways.
Yeah.
So, if we say R,
Fired.
3, 1. And we compute so we just say that T for the sake of it, 1 over that cancels out to 1.
What are you doing?
What? Did I do something?
Yeah, you
Hold on a second. By the way, it doesn't matter whether you put catalyzed or uncatalyzed on top or on the bottom. It doesn't matter as long as you're consistent on the other side. Over there, if I would have had K catalyzed over K uncatalyzed and then switch those two, it's the same answer. You get the same. All right. Now the catalyzed, of course, is AE to the negative EA over RT. Oh, over the same thing here.
Days cancel out.
Top is catalyzed, bottom is uncatalyzed. Okay, let's plug our numbers in. Catalyzed goes 2,500 times faster than that one. I don't know what the speeds are, but I just know that one compared to that one, that's all we're doing with ratios anyway. So it's 2,500 over 1.